Hello, we move on to here the angle sum property of a triangle under lines and angles. That's the last part under lines and angles. It's simple, which says the sum of all angles of a triangle is 180 degree. That means if I'm drawing this triangle, which I name as ABC angles, then angle A plus angle B plus angle C would give us 180 degree. This is one theorem, and the second one which says that if I draw this triangle, which I have already drawn, that is ABC, and I extend this side is produced to, suppose, the point D. Then the exterior angle, this is the exterior of the triangle, so the exterior angle is formed, which is equal to the sum of the two interior opposite angles. So angle C, that is ACD, is equal to the sum of angle A plus angle B. This is one more theorem under the angle sum property of the triangles. Now let's take up few questions. I draw a figure here. Based on this, we take up the question. I name them. This A, that is B, that is C, D, O. The sides AB and AC of the triangle is produced to the point E and D respectively. I then write the part of the questions which will be kind of important to us. Herein I am writing the question. It says, if the bisectors BO and CO, BO and CO are the bisectors of angle BCD and CBE, bisectors of angle CBE and angle BCD respectively, that meet at O, then prove that angle BOC is equal to 90 degree minus half of angle BAC. Now this question can also be read as a statement where they ask you to draw your own figure, like the same. I'll just take up the as a different figure for the same question and the solution. Herein you are asked to draw your own triangle, which reads, if the bisectors of angle ABC, there's a bisector of angle ABC is this one, which is BO, and the bisector of ACD is CO. They meet at the point O, and then you have to prove the same thing which I have written above. The solution will have no difference. Now let's see our own the basic figure, the first one which I had drawn. Angle CBE is bisected by this line BO, by this ray BO. So we can write angle CBE BO, this part, as half of that whole angle which is CBE. Now what is CBE? So this has been marked as Y, this as Z, and this also as X. These two angles will be equal for us. Let me mark the other two. Now how do you calculate angle CBE? As because ABE is a straight line, this whole is 180, and if this part is Y, we can write CB as 180 minus Y. Oh, sorry, I left this half part. Oh, I need to erase and rectify it properly. Sorry. We can write as half of 180 minus Y, which now if I open the bracket will be 90 minus half of Y. This is our first equation, let it be. On the other hand, BCD is bisected by the ratio. So angle BCO, this angle, will similarly be equal to half of angle BCD, and BCD can be replaced as 180 minus Z for the same reason as we had taken it as 180 minus Y. Removing the bracket will make it 90 minus half of Z. This is equation number 2. Now this triangle which is formed BOC, we have learned previously the sum of all the angles of this triangle will be 180. So angle BOC plus angle BCO plus angle CBO is equal to 180 degree. Now BOC, let it be on the left hand side because we have to find that part out, will be equal to 180 minus angle BCO minus angle CBO. So that makes, let us substitute our first and the second equation. So BCO was 90 minus half Y minus, it was 90 minus half Z. Let us remove the bracket, that will make 180 minus 90 plus half of Y minus 90 plus half of Z. So we are getting here as, okay, on the other hand I forgot to write angle, okay, this is BOC, this also BOC. Now BOC can also be written as then this is getting cancelled. Oh, I need some more space. I move on to the other screen. So it is BOC will be half of X plus half of Z. So I write it here. BOC will be half of Y plus half of Z, if let it be as half Y plus Z. Now I move on to the figure. We also see here that X, Y, Z in the triangle ABC, that is also equal to 180 degrees. So I carry that to the next screen, which reads X, oh sorry, let this be as our, suppose, the third equation I get. I also said that X plus Y plus Z equals 180 degree. That means Y plus Z can now be substituted as 180 minus X. So I'll substitute this in the equation 4. So angle BOC will now become half of 180 minus x, that makes it 90 minus half of x, and in the figure x was angle BAC, so this was half of angle BAC. So I hope you followed this. With the same solution will also be taken for the other figure which I had drawn along with it. Let's now move on to another question which I write here. If two parallel lines are intersected by a transversal, prove that the bisectors of the two pairs of interior angles enclose a rectangle. Let's now draw the figure for the said question. This is the parallel lines which is now intersected by a transversal. Let's name them first. This is A, B, C, D. Prove that the bisectors of two pairs of interior angles. Let us draw. This is an interior angle. Let me bisect that. I have to bisect this as well. Oh, that doesn't look like a bisector though. Anyways, I draw the bisector here. I'll also have to draw the bisector, and this is the figure it would look like. It says this looks like this encloses a rectangle, so we have to prove, suppose A, B, C, D, L, M. Okay, this can be E, F, G, H. That I could have made I, J, but it's okay. We have to prove this G, M, H, L to be a rectangle. Angle AGH and angle DHG. AGH is equal to angle DHG. They are alternate angles. So half of angle H will also be half of angle DHG. Now half of angle AGH is this, so we take it as AGM. This is half of angle it, so I'll write angle HGM will also be equal to half of this, so it is what do I write? GHL. Now this line GM or GL are intersected by GH. Now I highlight for you to look into it. I change the color. Look at it. GM and GL are are intersected by the transversal GH at the point G and H. Now these two angles which I have marked to be equal make the alternate interior angles for those two lines MG, HL and the transversal GH. When these two lines are parallel, that makes MGLH to be parallelogram. So we have now moved on to prove GMHL is a parallelogram because of the reason which you can write it there as because the alternate angles are equal. Now only once we prove one of the angles of this is 90 degree, that will make a parallelogram parallelogram a rectangle. That's the basic requirement for to make a parallelogram a rectangle. Now, how do we prove? Let's see. Okay, say BGH, this BGH plus DHG, I can write DHG equals 180y. Because it was given AB parallel to CD, therefore interior angles on the same side of transversals are supplementary. Every time you say something, you have to write it beside, because I have been speaking, so I'm not every time not writing the reason, and I'm just telling you. I would suggest every time you say something, you derive something, do write the reason beside it. Interior angles on the same side of transversal, you need to complete transversal, are supplementary. So half of BGH will also be, if I make this all divide by half, so this will be 90. Now half of BGH makes it LGH. We are considering this angle because we are more concerned with this inside part of the triangle, of the rectangle, plus DGH half will become LHG. The sum of these two equals 90 degree. Now look at the triangle LGH. If we look into the triangle which is LGH, we see the sum of the triangle angles will be 180 degree. So angle, this I'll mark it as, suppose angle, this one that we will be writing as, okay, how far I forgot. I'll just be writing angle 1 plus angle 2. So that is LGH plus angle G plus angle GLH. They make it 180 degree. Now this part is 90, which I am substituting here, plus angle GLH is 180 degrees. So we get GLH to be 180 minus 90, that gives us 90. So now we have proved this angle to be 90. You can also do the same with the other on the other side of the transversal. We had proved GMHL to be parallelogram. We have now proved one angle of that parallelogram to be 90 degree, thereby making GMHL to be a rectangle, which we were supposed to prove. Hope you got it, you followed it well. Thank you.